So basically what a derivative does is it gets you an equation for the slope of the tangent line at that point. So derivative gets you an equation for the slope of the tangent line at that point. Actually, for any slope of the tangent line of the curve. So in our last problem, we took y equals, or f of x equals 5x squared plus 3x minus 1, and we found f prime of a, which equals 10a plus 3. So this is the slope of the tangent line for any x value, or quote-unquote a value. So if I wanted to find the tangent line at x equals 1, at x equals 1, I plug in 1. So I say f prime of 1 equals 10 times 1 plus 3, which equals 13. So then, once I have that value, this is the slope at 1. I'd have to find the point, 1, f of 1. So I'm going to plug that into my original equation. That'll give me 5 plus 3 minus 1, so 7. So if I know the slope is 13, y equals 13x plus b. I can plug in my point, 1, 7. This is the point on the curve. So 7 equals 13 times 1 plus b. 7 equals 13 plus b. Subtract 13, so b equals negative 6. So the slope of the tangent line is y equals 13x minus 6. And that's the slope of the tangent line at x equals 1. Sorry. It's y equals 13x plus b, because 13 is the slope. And now we're going to plug in the point 1, 7. So 7 equals 13 times 1 plus b. 7 equals 13 plus b. Negative 6 equals b. So that slope of the tangent line to the curve at that point would be y equals 13x minus 6. And then, sometimes they tell you to graph both. So you want to graph the original curve, and so this is the tangent line, and then we'll graph the original curve, which was y equals 5x squared plus 3x minus 1. So negative b over 2a is going to help give me the vertex. This is a parabola, so I'm finding the vertex. So negative 3 over 2 times 5, so that's negative 3/10. Plug that into here to find out what the y value is. So that's, I'm just going to do that down here. 5 times negative 3 over 10 squared plus 3 times negative 3 over 10 minus 1. So that's negative 15 over, 5 times 9 over 100 plus negative 9 over 10 minus 1. So 45 over 100 minus, and I'm going to multiply both of these by 10 so I can get a common denominator. 90 over 100 minus 100 over 100. 45 minus 190. So that's 145 over 100 negative, which is negative 14.5. So, say I went by, these were 10, 20, so negative 3 tenths would be about here, and 14.5 would be 10 approximately here. If I plugged in 0, I would get negative 1, so here and here. So my parabola looks approximately like this. I also had that other point, which was 1, 7. So 1, 7, yeah, that's approximately right. So then I plug in the point 1, 7, and the tangent line was 13x minus 6. So I plug that. So here's the point. It was tangent to this point, 1, 7, remember? And then I just go negative 6 is about here, and it would, I'm sorry, negative 6 is about here. So up 6, 7, up here. So I go up 6, 7, so the tangent line is approximately